Hello and welcome to Environments Volume 2, Introduction to Clarisse. In this tutorial, we will go through the entire process of creating a very detailed environment using Clarisse, which is a very robust toolset for lighting, rendering, look development, and set dressing, commonly used in matte painting and environment creation. The tutorial is structured in a way that you will be able not only to understand how Clarisse works, but you will do it in a practical, hands-on way. First, we will learn the basics of Clarisse's interface and navigation. We will then learn how to create simple geometry and import custom assets and textures. We will also touch on core Clarisse concepts like context, instancing, creating combiners, scattering, and groups. We will then learn how to do some basic look development and scene lighting. We will also go through a very important part of Clarisse, set dressing. Finally, we will learn how to render our 3D scene while creating render layers and the final composite. Although this is not an advanced course, it will touch on all the necessary topics for you to start creating not only amazing environments, but in general amazing images in a fast and fun way. We have a lot of ground to cover, so let's get started. So before we dive into our actual project, I want to talk about why Clarisse and which are its main advantages over some other DCCs. So first of all, I'm going to talk about set dressing, and this is a very important aspect of Clarisse, one that separates it from other products. So set dressing in general means to add objects, details to your scene, create layouts in a very easy way, and sometimes even in a very fun way. So I'm going to start with a very simple example. Of course, as in any other 3D project, you can easily drag, rotate, scale your objects. So nothing new here. But there are very simple techniques that can make your life easier. For example, with my move tool, I can press S and click the object to immediately jump or snap into a specific location. Again, this is not a huge deal, but Clarisse has a couple of tools that will help a lot in this kind of process. For example, we can use a clone stamp tool to just click and place random objects based on a list of predefined objects, of course, but very easily position variations of this geometry in very specific locations. Another very interesting tool that makes set dressing quite easy and quite fun to do is the particle container combined with a particle paint tool. So for example, I'm going to click and drag to paint some shrubs here in the foreground. Probably paint additional ones back here. And finally, we have some very robust scattering tools that I will demonstrate here with these trees. So I'm going to zoom out, and you'll notice that I have quite a few trees back here scattered along the terrain. Now, another important feature, and to me it's quite impressive, probably one of the most impressive features in Clarisse, Clarisse is able to handle a huge amount of geometry. So right now, if we take a look at our point cloud object, we have 100 instances of this particular tree. Now, the tree is not a low resolution object. If I zoom in, for example, in one of these instances, you'll notice how it's quite detailed. Actually, each one of these trees is almost 2 million polygons. So again, I'm going to zoom out, and let's try scattering 10,000 of these trees. Now you'll see how the response is almost real time. So not really a huge difference between 100 and 10,000. And we can even go crazy. Let's try with 1 million. And there we go. So you can even take a look here to the top left. There's a primitive count. So right now we're hitting the 1.3 trillion polygons, and the system is handling quite well. I can even zoom in to see each individual leaf. So that alone is quite impressive. Now, another thing that I want to show you, and for now I'm going to reduce a bit this instance count. So another thing that I really like about Clarisse is that most of the time what you see is what you get, meaning that you're almost working real time, not only with your geometry, but also with your lighting, your textures. And this is what I mean. Clarisse has a very impressive progressive renderer. So while you're working your 3D space, Clarisse version of what your final image will be. So for now, let me turn off the wireframe. So I currently don't have any textures on the terrain, just to make this a bit easier to watch. But you can definitely see the textures on the trees, the shadows, of course. And we can even try rotating the lights. For example, let's go to our distant light. And let's try rotating it a bit. So there it is, the shadows are changing. Let's manually rotate this very gradually. And it's in real time how we have the. So this is important because when you're doing your look dev, your lighting, even your set dressing, you want to work as fast as you can and iterate as fast as you can. Usually the more iterations you can do, the better your images will start looking. And last but not least, Clarisse is a very fun tool to work with. So these are just a couple of reasons of why I really like to work with Clarisse when creating environments. One last thing I want to mention before we dive into creating our own environment is I will be providing some of the elements that you will see during the creation process, but unfortunately I won't be able to provide some library items that I used from Kitbash 3D and from the Speed3 library, since these are assets that I purchased and I don't have the right to distribute them. That being said, first of all, I will show you the web pages. So first of all, kitbash3d.com has a huge amount of very detailed sets, and if you go to kits, you can take a look at some of them. And the trees were purchased on speed3.com. You can go to the library and browse cinema trees. As for the assets that I will be including, these were all created in Houdini and they will be free to use in your projects, be them personal projects or professional projects. Okay, so I will go to File, Reference, File, and first of all I will load the camera. This will get you started with a point of view. So once you load an alembic camera, you can go to Look Through, Browse, and select the imported camera. Let's now bring in some of the terrain assets. So again, I'll go to File, Reference, File, and into the Alembics folder. First of all, I'll bring the bedrock. So notice how the model has a fair amount of detail. Of course, a lot was enhanced with the textures, but again, these are assets that you can use in many projects. I will now bring in the dunes. I will include two versions of the dunes. First of all, let me hide the bedrock asset. I will also hide dunes B. So notice how dunes A is larger, but it has a bit sharper edges. You could use the dune A as a background element, but it would be a bit difficult to tile. If we compare it with dune B, dune B is a bit smaller. This is the one I used for the actual environment, but I flattened out the edges. That way it would be easier to tile this element. Okay, so I will hide the dunes. and display the bedrock again. I will look through the camera. And this time I will import the VDB that was used to create the dust. So on my scene context, I will right click and type volume and look for volume file. And now I will load the provided VDB. So I'll go to file name. So under the VDB folder, I'll double click in dust generic A. And this is the volume. So what I try to do with this particular volume is make it so that it would be easy to tile around, so you won't notice any clipping or any seams on the edges. Okay, so I'm going to hide this asset. And finally, I'm going to import a bush geometry. So that is an OBJ. I will go to File, Import, Geometry. And under the OBJ folder, I'm going to load bush generic A. This particular object doesn't have materials, so you can say no to the prompt. And I will zoom into the bush so you can see it. Okay, so this is it. It has a fair amount of detail, so it can be quite useful to scatter around. It could even hold up in a foreground with some nice textures. Okay, so this is it. I hope these assets are useful. And now let's dive into creating our project. Before we dive into our project, let's get acquainted with Clarisse's interface and navigation tools. So first of all, in the center, we have the viewport window. To the left, we have a toolbar with most of the common tools that you will be using, like select, move, rotate, and scale. As usual, on the top, we have our main menu with some options like file, edit, and create. And we also have a couple of tool shelves with very important tools or tools that you will be using quite often. For example, geometry, lights, rendering, and particles. To the far right, we have a very important window called the Attribute Editor, where you will be able to change most of the attributes of an object. The image gallery, material linker, and layer editor we will talk about in later chapters. But for now, I do want to bring your attention to the browser widget or the browser pane. This is a very important window that will not only show us the scene hierarchy, but it will also allow us to select objects and even create objects using the right mouse button. As far as navigating the windows, you can Alt, click, and drag to orbit around your 3D scene. You can also press Alt and click your middle button to pan around the scene. Or you can use the mouse wheel to zoom in and out. Another important feature of the viewport window is you can select an object. For example, we could select a camera and press F to frame the viewport on that particular object. Let's now talk about kinematics and manipulating your objects in the viewports. First of all, we don't need the path tracer. I'll just delete it. Same for the image. We will talk about these in later chapters. I will definitely keep the camera and the light. So to start creating your own objects, you can go to the geometry shelf and just click on an object, for example, a grid. Now, if you select your polygrid, you'll notice on the attribute editor, you will have the grid's attributes or properties available. I will scroll down a bit to see the size properties of the grid, and I will increase the size to 1000 by 1000. Back on my viewport, I can press F to frame the grid in the viewport. Now, I already mentioned that the kinematics are basically the object transforms, or the position, the rotation, and the scale of an object. But you can also change the kinematics of an object directly on the viewports. For example, let's create a box and a sphere. Then I will click on the box in the browser window to select it, press F to frame it in the viewport, and now I can click directly on the Translate Item tool and then click and drag the cube either in one of the specific axes or in two axes at the same time by middle clicking one of the axes and dragging. For example, if I middle click in the y-axis, I will be able to translate the cube in X and Z. Or if I middle click on the x-axis, I will be able to drag the cube on Z and Y. Another super handy tool is you can press the S key and click on another object to snap the selected object in that specific place. Of course, I can also rotate the object or scale it. Now, the easiest way to do these transforms or to change the kinematics of an object is to press specific keyboards. For example, press the Q key to activate the select tool. Select your sphere and now press W. This will allow you to translate it. You can now press E to rotate it, or press R to scale it. You can also scale it in individual axes. Now you will notice below the Scale Item tool, there's a Transform Item tool. This is useful if you want to transform several objects at the same time. For example, you can shift and click the cube to select it as well. And now I can rotate them together. Notice how if I do this through the Rotate Item tool, I will be rotating them in their individual pivot points. Again, let's click on the Transform Item tool, and I can even rotate them based on the viewport. So this can be very handy. Let's now talk about a very important concept in Clarisse called context. If you take a look at our scene hierarchy, we have our project and then a folder called Scene. Inside this folder, we have a camera, a light, a path tracer, and an image. This scene folder is actually what we call a context. And contexts in Clarisse are very important for several reasons. First of all, they will let us organize the scene in a very clean way. But these contexts also have several very powerful uses. For example, you can render separate contexts with different rendering properties, or you can render different contexts with different lighting scenarios, or you can even use contexts to generate layers for compositing an image. But it's easier to see how they work in practice. So I will show you how I use these contexts in my Clarisse projects. To demonstrate how contexts work, let's first make a new blank scene. So you can go to File, New, Empty Scene. Notice how we don't have our camera, our lights anymore, and the scene folder is also gone. So let's create our own context. First of all, you can right-click on the project object, go to New, Context, and we can always rename these new folders pressing F2 and typing its new name. In this case, let's call this Scene Day. Now, inside this folder, I will create a grid. I will use this as a terrain or as a floor. So I will select the grid and change the size probably to 1000 by 1000. Let's frame the grid. And I will create a box. keyframe it. And I will use the translate item tool to position it somewhere around the grid. I will also create a sphere and a cylinder. I will show the caps of the cylinder so it renders as a solid. I will also scale the cube a bit and reposition it. Now what I'm going to do is within this scene day context, I will create a new folder or context and call this lights. So I'll press F2 and type lights. So as you can see, we will use these contexts to organize our scene. One other important thing that you might notice is that our grid and geometric objects disappeared. The reason why we cannot see them now is that the viewport is usually locked to a context by default. This means that the viewport will only show us the selected context. For example, scene day includes the polygrid, box, sphere, and cylinder, but the lights context is currently empty. This is why we don't see anything here on the viewport. To avoid this viewport switching, you can lock a specific context on a viewport by clicking and dragging it under the display selection list. Now, it won't matter which context you have selected, the scene day context will be locked in the viewport. So this is very important to remember. Okay, so what I'm going to do now is zoom out and I will create a couple of lights. First of all, go to the lighting shelf and create an environment light. And I will talk about this in a bit, but for now change the shading mode to progressive rendering. I will also increase the refinement for a bit to 10. I will now select the environment light and under the attribute editor, I will change its color and intensity. Now I will add a distant light, so click here on the distant light icon. In this particular case, the position of the distant light is not important, only its orientation. So let's rotate the light a bit. And again change its color. Okay, so this is fine. Now what I'm going to do is I'm going to copy the complete context. So you can select the scene day folder, press Ctrl C, and under your project press Ctrl V. Now we have this scene day 1 context. I'm going to type F2 to change the name and call it scene night. Now this context contains the exact same hierarchy and geometries that the scene day context. But what I'm going to do here is change the lighting conditions so it looks more like a night scene. So first of all, I'm going to lock this scene night context to the viewport. Dive into the lights folder or the lights context. Now something I just noticed that I forgot was to drag the lights into this folder. So I'm going to select distant light and environment light, drag them into the lights folder, and I will do the same in the scene night context. Just to keep the project ordered. Now, as I mentioned, I will decrease the distant light intensity to make the scene look as if it was a night scene. So I'll bring this down to 0.2 or even less, 0.1. I will also change its direction. And I will change the environment light to be a bit more blue. So again, I will change the color. And I will reduce the intensity to 0.2. Now, of course, this isn't a very fancy scene, but it will give you the idea. Now we have two identical scenes in terms of the geometry, but now we could render them with different lighting in a non-destructive workflow. So of course we will keep using these contexts as we work through our project, and with practice you will be able to not only understand the importance of these contexts, but how to use them and apply them in your day-to-day work. Okay, so the time has come for us to start working on the actual project. And to do so, we have to either create our own geometry or import it from other 3D packages or 3D libraries. Now, before we do that, I do want to organize my scene a bit. I'm going to create a few basic objects and contexts. So first of all, what I want to do is name my scene context depending on the sequence or shot or project that I'm working on. So I'm going to select the context, press F2, and call this DNS, as in dunes, _0010. And this is a relatively common naming convention where you want to have your sequence abbreviated and then the number of the actual scene. For example, you could have several scenes in a project, and you could increase this number depending on what shot you're working on. Okay, so a few other contexts that I usually like to create are my assets context, and another context called looks to create my look development. And inside the scene context, I will create a new one called lights, and another one called environment. Also, before we forget, let's save our scene. And with this, we should be ready to acquire our assets. Okay. So there are basically three different ways to acquire or generate geometry for your project. You can either create your geometry directly in your Clarisse scene. You can also create your objects in separate 3D applications and then import them into the scene. Or you could also use existing 3D object libraries and import the models into the scene. Sometimes these library objects also have textures, which could be very important. Now, before we actually do that, I want to show you a couple of very important libraries that I use a lot. First of all, there is SpeedTree. Actually, SpeedTree is a standalone program to create trees and foliage, but it also has a very nice library. So you can go to Cinema Trees and look for very realistic assets. Of course, you can buy them here and download them. So overall, I'd say SpeedTree has one of the most realistic collections for shrubs, trees, and plants out there. Another nice resource is Kitbash 3D. Kitbash has several collections or kits of different buildings and assets. So these can be a huge time saver if you're working alone or if you're working on small teams. Their collections have usually very detailed models that come with textures, which is a huge advantage. Another library that's very important is the Quixel Megascans. Quixel has a huge amount of not only 3D scanned objects, but also surfaces or textures. And Quixel has the added advantage that you can use a plugin to bring the assets directly into your scene with just a click of a button. Okay, so let's go back into our scene. And first of all, I will import a terrain that I created in Houdini using the techniques that we saw on Volume 1. This geometry was saved as an alembic. And to import an alembic, you can usually go to File, Reference, File, browse into your projects folder, and just double click on the file you want to import. Now, one thing I usually do is bring in this object into my assets context, and then I can instance this into my scenes folder. And while we're here, I will also import a dunes geometry that I also created in Houdini. So I will go to File, Reference File, and bring in the dunes B geometry. Okay, so as I mentioned before, these geometries are currently in the assets folder or the assets context. What I want to do is bring them into my scene, and not only to the scene but to the environment folder. To do that, I will right click on the asset I want to instance, drag it on top of the folder, and select Create Instance here. Now, I will talk about what exactly an instance is in just a moment. In the meantime, I will also add the dunes object as an instance into the environment context. Okay, now let's import a couple of trees. I'll go to my asset folder. I will create a new context. I will call it speed tree. I'll double click inside this folder. And my speed tree objects are OBJ files. To import OBJs, you can go to File, Import Geometry, browse into your folder, and just double click on the geometry you want to import. Now, a nice feature of the OBJ format is that it can sometimes come with an assigned material or a referenced material and textures. So what this window is asking, if I want to create the materials as well, I'll just click yes. And it might take a while depending on the size of the file. But notice how we now have a bark material, a font stem material, and a couple of textures that have been brought in with the entire geometry. Another thing that I will be using quite a lot in this particular scene is some Kitbash 3D assets, particularly buildings. So what I'm going to do is on my asset context, I will create a new folder, and this time I will call this folder buildings. So inside this folder, I will do the same. I will import an OBJ object. I will go to File, Import Geometry, and I will look for my 3D geometry. Again, I will import materials and textures. And this should be now ready to render. So what I'm going to do now is finish importing my Kitbash 3D and my speed tree models, and I'll come right back in a few minutes. Okay, so I have finished importing all my speed tree assets as well as my buildings from the Kitbash 3D. But still I have a couple of objects to be imported. First of all, I will import a VDB to represent the dust in the environment, and I will also need my camera that was saved as an alembic from Houdini. So first of all, in assets, let's create a new context. Let's name this new context volumes. And let's dive into the folder. Now, to import a VDB, you can right-click on the browser window, go to New, Geometry, and look for Volume File. Now, with the file selected, go to the Attributes Editor, and under File Name, browse for your VDB. Okay, so let's rename this volume. Let's call it Dust A. And now I'm going to instance it to my scene. But first I'm going to create another volume context within the scene. And instance my VDB from the assets context to the scene context. And there it is. Okay, so finally let's bring in the camera. Before I do that, I'm going to hide this volume temporarily. You can do that by selecting the object and pressing Ctrl D. Okay, so the camera I'm going to import directly under my scene context. So I'll go to File, Reference File, and import my camera. Now, if you want to look through the camera, you can go to this eye icon, click on Browse, and select the camera you just imported. Now that we have imported all our assets, and before we jump into layout and set dressing, I want to talk briefly about shading modes. Before I do that, let me jump out of the camera view. I can do that by pressing the L key on the viewport and probably zoom in a bit on the terrain. So the shading modes can be changed here on this sphere icon. The most simple shading mode is wireframe, and it's also usually the fastest. We can also choose between constant, normals, simple shading, previous, and progressive rendering. So let's take a look at simple shading. So this is just a very simple representation with object colors. We can also use the previous mode, which will usually show you textures when the objects have them. In this case, we still don't have textures. And we also go into progressive rendering, and this will give you a very accurate representation of how your final render is going to look. So this is very powerful. Now, we can also combine these modes with a few other options. For example, you can always turn on your wireframe. Another nice option, if you go to, for example, simple shading, is to turn on ambient occlusion. And finally, you can turn up the refinement count to have a much smoother view, or you can bring it down just to have a faster feedback on your viewport. Okay, so for now, I will keep this in simple shading with ambient occlusion. This is fine for now. And now we can continue with our next topic. Okay, so with our camera ready, let's start talking about a very important topic within Clarisse, which is instances. So I have mentioned instances before, and I have actually created a few of them, but I haven't really explained how they work and also why they're so powerful within Clarisse. So as an example, I'm going to look into my assets folder. Within the speed tree folder, I have a collection of shrubs and trees. So inside we'll have the fire bush, and I have 4 or 5 different variations of these geometries. So what I'm going to do is, first of all, create within the environment context a new context called shrubs. So remember, press F2 to rename a folder. And I will create my instances in here. So back to my asset. I'm going to right click and drag into my shrubs context. I'm going to create an instance. Now here is the instance. I will press the W key to be able to translate the shrub. Now if I go back to my asset folder, select the original shrub, you will notice how the translation has also changed. So let's revert the translation to 0. And now you'll notice that the instance is also changing. So every single property that the object has is inherited into the instances. So that's powerful, but sometimes you want to avoid this behavior. So to do that, let's go back to the instance, select it, and what I'm going to do is here under Translate, I'm going to right click and click on the Localize option. Now I will translate it again, and if I now go back to my original object, notice how the translations are back at 0. So by localizing parameters or attributes, you can break this connection. For example, let's also localize rotations and scales. Now let's do this. I'll press Ctrl C to copy this object and then Ctrl V to paste it. Now I have 2 different objects or instances of the original, but each one will have its translations. Okay, so let's bring in a couple of more variations. Let's go back to our assets. I can select all 4 remaining variations, and again right click and drag to the environment shrubs context and make sure to create instances here. So let's go back to our context, and sure enough we'll have all the variations here. Okay, so now before we continue, let's lock this geometry, the terrain. That way we're not accidentally selecting it. So you can go to the General tab and then click on Lock. Okay, so now let's start set dressing our scene. First of all, let's look through the camera. So on the look through icon, make sure to select the loaded camera. Now, first thing I see is that the shrubs are a bit out of proportion. They seem a bit large. So let's first of all change the scale. And I could select all of them and change the scale at once. So I'll Control click and drag the scale parameter until they seem more or less at the correct size. Okay, now remember we talked about snapping objects to geometry. So with that Translate tool selected, you can press S and click to snap the objects to the terrain. For example, let's do the same with this one. I'll press S, click on the terrain, and we can continue to do this. This particular one, I'll make it smaller. So I'll press Control, click and drag on the scale. And probably this one as well. Okay, so the snap tool is nice and quite handy, but I want to show you another tool that will help us create a very quick set dressing and a very quick layout. So on the main toolbar, we'll have the Clone Stamp 3D tool. So double click on that tool and you will get some properties. First of all, here are the sources. Sources are the objects that will be cloned whenever you click with this tool. So let's add our 5 bush variations. Click on the Add button, then go to your scene, Environment, Shrubs, and you can control-click on each one, and then click Apply. Okay, now that we have defined the objects that will be cloned, you can add some variations. So these are random variations that will change whenever you clone the object. So first of all, let's change the rotation variance to 360 degrees. Let's also change the uniform scaling variance to, say, 15%. And for now, let's go with that. So you can now close the properties. And notice now, whenever I click on the terrain, I will have a bush generated. Of course, it's snapping to the geometry, so this could be very handy. So let me undo a couple of clicks. Since this is a desertic terrain, I want most of the bushes to be without leaves. So first of all, let me take a look at which are the ones that I want to clone. So one of them is the forest, and the other one is the field. So let's go with only those two. Again, you can double click on the clone stamp tool, and you can remove the ones you don't want. Just press delete. Again, select and delete. And let's try now. Okay, so this is working quite nice. You'll notice how the clone stamp tool can be very handy. For now, let's make sure to save the project. You can press Ctrl S, and in a moment I'll be back to talk about the particle paint, which is also a very powerful tool. Okay, so now let's talk about a very important topic, which is scattering. And within Clarisse, scattering can be done in several ways. On this particular lesson, we're going to use a scatterer in combination with a particle container and a particle paint that you can find on the main toolbar. So first of all, let's go ahead and prepare our layout. If you remember my final render, I want some water to be centered here on the view. So first of all, let's create a geometry just to give us an idea of where the water will be. Make sure you're under your project folder, under Environment, and here we're going to create a grid. So go to the Geometry tab and click on the grid object. So first of all, let's name this grid Water. And you'll see it here, it's very tiny. What I'm going to do is increase its overall size to about 70 meters. So now we can see it here. One other thing I'm going to do is I'm going to change the display color to blue. Okay, so I'm going to press L on my viewport and orbit around the water plane I just created, just to have an idea of where I want to paint these plants. What I'm going to do is create some underwater vegetation so we can see through the water a bit. I don't want them to be very obvious, but it will be a good opportunity to show you these new tools. Okay, so now that I have my water plane created, I'm going to create a new context for the water plants. It can be here within the environment. So I'm going to right click, go to New Context, press F2, and name this new context Water Plants. Dive inside the folder. And for now, I'm going to disable the water. I don't really need to see it anymore. So with the water selected, you can press Ctrl D. And now I know I'm going to paint around this centered area. Okay, so now we're ready to start painting our plants. So double click on the water plants folder to dive in. And first of all, we need to create a scatterer object. So you can right click on the browser, you can either go to New and find the scatterer, or you could also start typing SCA and find the scatterer object in the window. Okay, so first thing we need to do is define which objects I want to copy or scatter with the scatterer object. So what I'm going to do is, under the attribute editor, look for the geometries list and click on Add Row. Now I'm going to Assets, Speed Tree, under my Firebush folder, and for this particular scatter I'm only going to use the seedling. Okay, so now we need to create a point cloud, or in this case a particle container, that will be linked to this scatterer object. So again, you can right click on your browser window, go to New, Geometry, Particle Container. Okay, so with the container created, select your scatterer object and look for the geometry support. We need to link this to the container. And now we're ready to create the actual particles using the paint tool. So make sure that your container is selected and then double click on the particle paint tool to look at the options. Okay, so first of all, we can increase the brush size considerably since this is a very large terrain. And let's start with this. If I click and drag, you'll notice that some points are being created and immediately my plant is being scattered onto those points. And since you can paint directly on your viewports, you will have a lot of control of where you want to place these instances. So let's decrease the size of the brush and let's try to increase the density. So this is the amount of points that will be painted on a certain area. I will even decrease the size a bit more. And again, this is just an example, so feel free to paint around where you really want these plants to be. So for now, I'm going to close the attributes. I'm going to zoom into my instances. And if you take a look now, most of them look identical. So let's fix that. I'm going to select my scatter object and probably add some randomness. So look for the variance options. I'm going to change the scatter rotation variance to 360 degrees. This way they are pointing in different directions. And I will also increase the scale variance. So I'm going to click and drag on the parameter. This will make the scattering look much more natural. So let's go ahead and look through the camera. Let's see what we have so far. So right now I've painted most of the plants out of the camera frustum. I want to paint a little bit more here where I can see them. So I'll just select my container, click and drag on my viewport. Now remember, most of these plants will be underwater, so it's fine to have a lot of them. It's just to give a bit of texture and some detail to our lake. Okay, so let's turn on our water surface. Select the water grid and press Shift D. I will now press Ctrl D and paint some more, probably on the edge of the lake. So let's go back to the water plants. Select the container and paint some more. Okay, let's go with this. Make sure to save your file. Again, you can display the water surface. Press Shift D to display it. And now let's move on exploring some other tools. Okay, so in the previous lesson, we used the scatterer in combination with a particle container to create our underwater plants. In this lesson, we will create another scatterer, but this time we'll use a point cloud to scatter some palms on the dunes geometry. So first of all, let's go to the environment context and let's create a new context. So go to New, context, press F2 to rename this folder, and let's call it palms. I'll dive inside and create a new scatterer by right-clicking on the browser window. I'll go to New, Scatterer. Now, as I mentioned before, we'll need a point cloud this time. So again, right-click, go to New, Geometry, Particle, Point Cloud. Okay, so first of all, what I'm going to do is scatter these points on the dune geometry. So I will select the dune geometry and press L to jump out of the camera view. Press F to frame the dune's geometry. And now back to my palms environment. I'm going to select my point cloud, and in the attribute editor, I'm going to scroll down a bit and look for the geometry parameter. So here I'm going to select the dune's geometry that should be under my scene context, under environment. So double click on dunes. And notice how by default the point count for this point cloud is 0. Let's increase a point cloud to 1000. And now you'll notice that although the points have been created, they don't appear to be in the correct position. Now, if you select the dunes, you'll notice that the dunes are offset from the world, so they have been transformed. What we could do to fix this issue is select our point cloud and parent the point cloud to the dunes. This should not only move the points towards the geometry, but also if we were to move the dunes from this current place, the particles would follow. So again, under the attributes editor, look for the parent parameter and again select the dunes geometry. Okay, now this fixed the issue. Just a heads up, if I go to Edit, Preferences, Layout, you'll notice how Parent in Place is turned off. This is important because if Parent in Place is turned on, whenever you link an object to other, it won't move or jump to its current transforms. It would just keep it in place. Okay, so with this done, I'll select my scatterer and point it to this point cloud. So in the attributes editor, go to Geometry Support and select the recently created point cloud. Okay, so final thing I need to do is under the scatterer, under the geometries list, I'm going to add the geometry that I want to scatter on this point. So under my assets, I'll go to Speed Tree. Under the Palm Chinese Fan folder, I will select the Chinese Fan OBJ. Okay, so now we have the palms created. A couple of things. First of all, I want a few more variations. So let's start with that. I'll select again my scatterer and I'll click on Add Row. That way I can select several objects at once. This time I'm going to my Palm Queen folder and I'll select Field and Forest and click on Apply. So now we'll have a couple of variations from the Queen Palm and a couple of them will be the Fan Palm. Okay, so this is working. Let's try decreasing the amount of palms first. So I'll go to my point cloud, bring down the point count to around 40. And again, let's look through our camera. So the count seems fine. One thing is the palms look quite large at this point. So let's reduce the scale of the original assets. I'm going to navigate to my Palm Queen folder, select all of the palms and scale them down. So I'll control click and drag the scale parameter, more or less like this. And I'll do the same with the Chinese Fan. I'll control click and drag. to bring the scale down. Okay, I think this will work. Now that I'm happy with the amount of palms and the distribution, I'm going to randomize both the scale and the orientation. So let's select the scatterer. Under the attribute editor, let's find the variance parameters. First of all, let's increase the rotation variance to 360 degrees. And we're going to do the same for the scale. I'll control click and drag the scale values. And I'll go with 15%. Okay, so as you can see, the scatterer is a very powerful tool that we will be using a lot in environment creation. As a side note, for this particular scene, I didn't use the point cloud to scatter the palms. I did end up using the particle paint and the clone stamp, but I would recommend you to go ahead and experiment and use whatever tools you're more comfortable with. Okay, so let's move along and start adding some buildings. Okay, so we'll start adding buildings to our environment. And throughout the tutorial, we have imported several assets. I also went ahead and imported the Outpost kit from Kitbash 3D, which has a lot of very cool buildings. So let's take a look at those assets. I will click and drag the buildings context to the display list to lock the context on the viewport. And as you can see, the kit has a lot of very cool buildings. So what I want to do is create some walls, and I will use some of these scribbles and pieces to make a more complex building. So I'm sure I want to use this wall, and I may use a couple of these smaller pieces. So what I'm going to do is create a new context or folder within my buildings context. I will right click, go to new context, and name this new context Combiners. Now within my buildings context, I will select the wall, probably a few panels and gribbles. Now I'm going to create instances of these objects in the new context that I created. And this time let's lock the Combiners context on our viewport. Okay, so let's bring all these pieces together. Frame the view. And again, I'm not sure if I'm going to use all of them. I'll just try to create a more complex object. Now, something very important that I forgot to do, you may want to localize the transforms for these objects before you do this. I'll just go ahead and do it now. So I'll select all of the objects, go to their kinematics, and localize, translate, rotate, and scale. Okay, so let's continue. I notice some of these objects have different Y position. So I'll select them all together, and I will change their Y position to 2.9 to match the position of the wall. Probably scale a few of these. So whatever you think looks interesting. I don't want to take too much time doing this. So once I have the objects in place, I will select them all. And here on my browser window, I will right click and select the combine option. Now this new object called a combiner will include all these assets and can be replicated, transformed, cloned, or whatever we've been doing with the rest of the objects in the scene. Okay, so I will undo these few transforms I did. And now I want to add this combiner to my environment. First of all, I'm going to change its name. I will call it wall combiner. And now I will right click and drag to the building's context that we created earlier. So I will create the instance. And now if we lock our shot context to the viewport, you'll notice we have our combiner there. This one in particular is in position, but now I can copy it into several places. For example, I can press Ctrl C to copy it and then Ctrl V to paste it. Let's now localize the transforms for both of these combiners. That way we can move them separately. I'll probably want to look through my camera now. And again, I can copy and paste. To add a few more walls. Okay, so I will leave it up to you to keep adding to your layout, and of course try practicing with these new techniques. Okay, so let's add the final touches to our layout. Again, I will go to my buildings assets. I will select a couple of these buildings and add them to the terrain. I will select my viewport and press L to get out of the camera view. Frame the terrain. And add a couple of buildings. So in my buildings folder, I will select a couple of them. Once selected, I will right-click and drag to my buildings folder within the shot. I will create instances of these objects here. And first of all, I will localize their properties, namely the transforms. So I will localize translate, rotate, and scale. I will frame them in my viewport. And then just manually position them and scale them to my liking. So I will press S and click on the terrain. Same for this other small building. And at this point you may want to look through your camera. So I'm just manually positioning them. And I might even try scaling them a bit. Or even copying them, rotating them. Whatever you feel looks good. So I'll press Ctrl C, Ctrl V. Move this building to the left. Rotate it in Y. Probably even scale it a bit more. You can also check your perspective view if everything is in order. So at this point, just have fun, get creative, and make sure to enjoy the process. Again, let's see through the camera, see what we got so far. And I think I'm liking this very much. Let's go with this. Make sure you save your file, and we'll come back later to add some lights and some textures to the environment. It's now time to start adding some nice lighting to our scene. Now, you may remember that when you created the scene, you get this first default light, and this is important because without it we wouldn't be able to see our scene through the progressive render. Let me show you what I mean. I will change my shading mode from simple shading to progressive rendering. Now let's try deleting the light. Just select it in the browser window and press delete. And as you can see now, the entire scene has gone black. So it's fine not to have lights if you're working on simple shading or previous views, but whenever you're going to start working in progressive, you will definitely want to start adding your own lights. So let's do that now. I will navigate to my lights folder. Remember, we created this context a couple of chapters ago, so it's time to make good use of it. So make sure to click on the lighting shelf. And first of all, let's create an environment light. Just click on the environment light tool. And now let's take a look at the light's properties. So make sure to select the light on the browser window. And here to the right, under the attribute editor, scroll down until you see the color, exposure, and intensity. These are probably the three most common parameters that you will be changing on the light. So let's start by reducing the intensity to something like 0.15. I will also try changing the color. Okay, let's go with that. And now let's create a distant light to emulate the sun. So make sure to select the distant light in the browser window. And again, let's change its color. This time I will go with something orange. Of course, I will desaturate it as well. I will leave the intensity as is with a value of 1. But what I'm going to do with this particular light is I'm going to change the angle by rotating it in X and Y. Let's try with minus 70 degrees and something around minus 60 degrees in Y. So the cool thing, as I mentioned before, is most of these changes you're seeing in almost real time. And again, if you go to your shading mode, we're currently working on progressive rendering. So you can really go a long way with these two lights, but now I want to show you a very powerful technique using image-based lighting. So I will select these two lights, I will delete them, and this time under the lighting shelf, look for the IBL tool or image-based lighting. I will click on that tool. And now you will be prompted to look for an HDRI image to create your lighting. In my case, I will go to my textures folder and load the texture that I downloaded from HDRI Haven. So now we'll get a much more interesting and realistic lighting condition. Now we can do a couple of changes. First of all, if you select your IBL light, you can again change the intensity or exposure. For example, you can try increasing the exposure to get more light, or perhaps go the other way and reduce its value. And of course, you can also rotate the light as we did earlier. Let's try rotating the light by 180 degrees. And I think I'm going to go with this. Finally, one more important thing that I want to mention. If you scroll down in your attribute editor, you will notice a parameter that's called unseen by camera. This parameter is turned on by default. So if you turn this parameter off, you will be able to see your HDRI in the background. Now, in this particular scene, I did left it turned off, but in some cases it would be important to maintain the HDRI on if you also want to render it with your image. Okay, so I will turn on unseen by camera again. I'll make sure to save the file by pressing Ctrl S, and I will come back in a moment. let's now talk about creating materials and textures, what's commonly known in production as look development. So if you take a look at my project context, I did create an asset context and also a look dev context. Here I imported the materials for the Outpost kit. Now what I'm going to do is create another folder or another context inside the look dev folder. I'm going to call this one water and dive inside the folder. Now in Clarisse you have several choices of materials, and in this tutorial I will create a few of the most common ones. So let's start with a standard material. You can right click on the browser window, go to New, Material, and look for Standard. So this is Clarisse's standard physical material. Okay, so with that done, let's change the name of this material to water material or water mat. And remember we hid the water geometry. So I will go back to my environment, select my water and press Shift D to make it active again. Now, first of all, if you have your water selected, you can take at the material linker window. This will tell you which material this selected object has assigned. In this case, it has a default material, it has no clipping map, and it has no displacement. So in this chapter, I will go through the materials and displacement. Okay, so with our material created, there are several ways to assign them. First of all, you can go inside the material linker, click on the material tab, and just browse from your project. You can also go to the material directly, in this case to look dev water, and drag and drop the material to the actual object. So now if you take a look again at the material linker, we have assigned the water material to the water surface. Okay, so before we go in and construct a more complex material, let's select the material and take a look at its basic properties, or at least the ones that you're going to be using the most. So go to the attribute editor and notice you have a diffuse tab. This is basically the color of your object. Another common property that you will be changing is the specular. And if you scroll down, you will find the transmission, which is related to the transparency of the object. Okay, so let's start with the basics. Let's try changing the color of the water. So in this case, click on the diffuse color swatch. And let's try adding a blue color. So let's go with a darker shade of blue. Now, aside from the color, you will usually have what's called the strength of that particular value. For example, by default, the diffuse strength of the material is 100%, but you can reduce this percentage until you reach 0. Once you reach a value of 0, this color is practically not applied to the diffuse component of the material. And actually, most of the time, water materials won't need a diffuse component. So, although in my final material I will keep my diffuse strength at 0, I will bring it back up to 100% so I can show you how to create a texture for this material. Okay, so before I show you that, I want to show you the specular component. So notice two things. First of all, the specular color by default is white, which is usually fine. Of course, we talked about the strength, but I want to bring your attention to this roughness component. The roughness defines how specular or how diffuse the reflections will be perceived on the surface. For example, if we bring down the value to 0, this surface will be almost like a mirror. So if you take a look at the water now, we can clearly see the building reflected from the background. Now, if we go the other way, let's try increasing the roughness to 60%. We will barely see any kind of reflections because now they're almost completely diffused. So if you think about it, materials like wood, paper, cardboard would have relatively high roughness values, and materials like water, glass will have very low values. So in this case, for our water material, let's go with a very low value. Let's say 5%. So this will let me see some reflections, but they won't be perfectly sharp, which is fine. Okay, so finally, one very important component, especially speaking about transparent or translucent objects, is the transmission. So by default, the transmission is usually 0. If we bring the strength to 100, it will transmit a great amount of light through the object surface. Now, at this point, if we were to decrease the specular component to 0, this material will technically be completely transparent, which of course is not natural. You always need to have both components, the specular and the transmission, to have a realistic material. For now, I will leave the specular strength to 0 because I want to show you a very interesting component of the transmission, which is the transmission scatter. And this is something I used for this particular render. So imagine we want to create a murky water, or probably you're rendering some kind of fluid like a juice or honey. Usually these surfaces are not completely clear or transparent. So in this case, to simulate this murkiness on the water, I'm going to increase the transmission density, let's say to 2. Now you won't notice a great change because the transmission scatter color is set to black. So we need to make a lighter color for the transmission scatter to be apparent in our material. So let's click on the color swatch. Let's make this color lighter. And you'll start to notice that we get some kind of density or murkiness on the water surface, which is quite cool. Now, let's try to give it a greenish tint. For example, think of the plants and moss that could be below the water surface. Try not to make it too bright. I usually go with dark colors because you usually want a subtle effect. So for now, let's go with this. And back to the transmittance density. The higher this number is, the thicker will be the appearance of this volume. So let's try reducing the density to 1. And as usual, I will leave it up to you to decide which values you want to use. In my case, I still want to see the plants that we scatter beneath the surface. And I would also like to see a little bit of the rocky texture that we're going to create in a moment. Okay, so now to talk about the textures, I will go back to my original opaque material just to better understand what I'm going to explain next. So I will change the transmission strength to 0 again. Make sure that my specular component is also down to 0. And what I want to show now is how to change values or create value variations for a specific component. For example, right now we're using a flat blue color for the diffuse component. So to be able to edit this material further, we can go to our browser window and double click our water material. This will bring the material editor, which will let you edit the material in a much more complex way. Now, I talked about textures, and in general, textures can either be files created in external programs or probably pictures or scans. And most 3D applications will also give you the option to create procedural textures. So let's start with that. I'm going to create a noise pattern and I will apply it to the diffuse component. So you can right click on the material editor and start typing noise. And you'll notice we have several noise options: cellular, fractal, and Perlin. In this particular case, I will create a Perlin noise. And I will connect it to the diffuse front color of my material. So notice how something changed here in my render. We don't have that distinctive blue anymore. Now the color appears to be gray. So let's select our Perlin noise texture and let's take a look at its properties. So one thing you can do, instead of having this floating window, you can add the material window on your main interface. In this case, since I'm not using the image gallery, I will swap this window with the material editor. And by default, whatever material you have selected will be highlighted on the material editor. So again, I will select my Perlin noise texture and take a look at its properties. So notice how by default it is being applied based on UV coordinates, which in this case is fine. So if you scroll a bit downward, you will see the UV scale for this texture. Let's try decreasing the scale. So I'll control click and drag the scale. And notice how some patterns start to appear. I think we can go much lower. Let's try with 0.1. And now we're starting to get something. So let's see what other options we have. We can increase the amplitude of the texture. This will generally give it a more contrasty look. And I think I can even go lower with the scale. I'll go with 0.01. Okay, so this looks good. Of course, you can change the noise colors. The default is black and white, which in this case is fine. You can change the linearity if you want to make a more complex pattern. And one other important value is offset. So the offset value can bias the color towards color 1 or color 2, which can be quite useful. Okay, so let's go with that for now. I will put aside the texture. I will use that later. I will disconnect it for now. And let's try to create the basic water shader. So select your water material. And remember we mentioned we probably don't want the diffuse component. So let's bring down the strength to 0. We definitely want the specular component. Let's start with 100. We'll bring it down if necessary. And let's go to our transmission and make sure to increase the transmission strength to 100. Okay, so we're getting a little bit of that green from the transmission scatter, but I would really like to see a bit more through this water surface. So I'm going to bring down the specular strength. Let's try with 75%. And this is more what I had in mind. Now, for the basic parameters, I say that we could go with this for now, but there's definitely something missing. Right now, the water seems completely flat, almost like a mirror. So I want to add a bit of detail using a bump or a normal map with the noise texture that we just created. Now, if you take a look at your material parameters, you will have a normal input. So you can use a texture to disturb the normals of the surface so it looks bumpy or rough. We're going to do that with the fractal noise. But before we do that, we need to create a normal texture. So I'm pressing Alt, and with the middle button, I'm clicking and dragging to pan around this material editor. And you can also use the mouse wheel to zoom in and out. So what I'm going to do now is right click on the window and type bump. You will notice that the bump map appears. So I'll create a bump map and I will connect my texture to the bump input and then the output of the bump texture to the normal input of the material. So notice how this bump is distorting the water surface, which will make for a much more convincing water surface. Now, it may probably be too high, so if you select the bump map texture, you can look into its attributes and look at the input amount. The default is 1 meter. We can definitely bring this down. Let's try with 0.1 meters. And this is starting to look much nicer. So let's leave the water material for now and let's move on to this rocky surface for the environment. Let's now create a material for a rocky surface using a principled shader. So first of all, let's go to our lookDev context and create a new context. Let's call this one Rock Mossy. Dive inside the folder. And this time I will right click, go to New, Material, and I will use the Disney Principled material. This kind of material is important because you'll find the principled material across many 3D applications. Now this material will have very similar attributes than the standard material. For example, it will have a diffuse component, a reflective component, a transmissive component, just as we saw with the standard material. But in this particular exercise, I will use photographic textures to change these parameters. This way we can achieve very realistic materials. So first of all, let's import the textures. These particular textures I downloaded from Quixel Megascans, but currently there's a lot of web pages that offer free textures that you can use. Okay, so let's go to File, Import, Texture, Map File. And in my case, I will navigate to Textures, Moss Rock, and I will select all of these textures except the displacement JPEG because we're going to use a displacement EXR, and click in Open. So with the textures imported, we're ready to apply them to our material. So first of all, I want to take care of the diffuse component, and in case of the principled shader, this would be the base color. So I'm going to use the albedo texture to drive the base color of the material. So first of all, let's take a look at the texture. You can double click a texture file to take a look at it in the texture view. So notice how this is a very nice mossy texture. And to apply it to the material, you can click and drag it directly to the material editor and then just make the connection. So click the output of this texture to the input of the material in the base color parameter. Now remember, we haven't assigned this material to the actual geometry. So let's do that now. Click on your material and drag on top of your object. Okay, so this is looking promising. Notice how currently the material is very shiny. And remember, this is due to the specular or the reflective property of the material. So select your material and under your attribute editor, navigate to the base parameters. There you will find the base color and specular. So if you bring specular to 0, you'll notice now the reflection is completely gone. So of course we don't want that, but what I want to do now is control the reflection of the rock with a texture, just as we did with the base color. So in this case, what I'm going to do is drag the roughness texture to my material editor. I'm going to connect the roughness map to the roughness value of the material. And now make sure to increase the specular value to 100. And now we have a very nice looking mossy rock. Now, something very important to consider is that most of the objects in real life, if not all of them, reflect light at some degree. So usually you don't want to completely kill the specular attribute. You definitely always want some amount of specularity, but you can change the roughness of your surface using texture maps, as we're doing here. This is a very common way to achieve very realistic materials. Okay, so for the water surface, we used a texture to displace the normals of the geometry to make it seem as it had some kind of roughness on the surface. For this particular material, or actually for this particular object, I don't want to use bump maps. I rather use displacement. And as we saw earlier, in the material linker, you have a special place to add a displacement map. And this is exactly what we're going to use. So in your browser window, right-click, go to New, and find Displacement. Now, there's two things we need to do. First of all, link the displacement to the object. So in the material linker, go to its displacement and find the displacement material. And one more thing we need to do is connect a texture to the front value. So in this case, I will use the displacement texture, drag it into my material editor, and connect the output to the input of the displacement. So now you'll start to notice we're getting much more detail on the terrain surface. So for now, to make it more evident, I will increase the front value to about 6. And of course this is way too much, but it will show you how the terrain surface is bulging out and giving it much more detail. So let's go back to 1 meter. Let's rename our displacement to rock mossy displacement. Make sure to save your file. And what I'm going to do is create the dunes material and come back with you in a moment. Okay, so it's now time to talk about volume materials. And before we begin, I do want to mention that I created a material for the dunes, and I noticed we had some broken materials for some of the buildings in the background that I also take the time to fix. So let's continue now. Remember that we imported a volume. It's under our volumes context. The thing is, we disabled it using Control D. So to enable it back again, I will press Shift D. And now our perspective has gone completely black. The thing is, the volume is right on top of the camera, and it also has a very dense default material. So I will jump out of the camera view by pressing L. I will press F to frame the volume. And notice how it's very, very thick, and it's also completely covering our camera. So first things first, let's try creating our material. Again, I will go to my look dev context, and this time I will create a new folder. I will call it volumes. Dive inside, and I will create a new material volume. So let's start by renaming this volume. Let's call it dust volume. We can click and drag it on top of our BDB. And volumes are relatively easy to control. There are mainly 2 things that you want to look for. First of all, the albedo, or the color of the volume, and the density multiplier. Let's start by changing the color or albedo of this volume. So click on the color swatch just to see how this looks. I'll make it a very bright yellow. So of course this is not what I like in this case, but it will give you a very good idea of how the albedo will influence the volume. Okay, so in this particular scene, I want to go with a slightly red volume. So I'll go back to my color swatch. Change the red value to 0.5, green to 0.45, and blue to 0.45 as well. Perfect. Now, one thing is I want a very light volume. This is going to be sand blowing in the dunes. I don't want it to be extremely dense. So on the density multiplier, let's bring the value down to 0.05. Okay, so this is more like it. It may still be too dense, but let's try and see this through the camera. First of all, I'll select the volume, bring it backward a bit, probably a bit to the left, and we may also need to scale it. But again, let's take a look through the camera, just make sure it's on the right position. I'm going to copy the volume by pressing Ctrl C and then Ctrl V. And this new volume I'm going to shift towards the right. Now notice how they are moving together, again to localize the transforms. So I'll press Ctrl C, right click on Translate and Localize. Same for Rotate and Scale. And let's try now. Click and drag to the right. And I think this is working quite nice. Let's go back to the volume material. And again, let's try decreasing the density. Let's go with 0.005. And now I think I went too far. Okay, so I will try to balance this value. And I think I'm going to go with 0.02. So I will save the file. And finally, what I want to do before going into rendering is to create an overall ambience. And this I will also do by creating a volume. So first of all, I will go to my shot context, volumes, select dust A and dust A1 and disable them by pressing Ctrl D. And now to create our environment volume, I will right click on the browser widget, go to New, Geometry, Volume Box. Okay, so the volume box is here. It's quite small. I will bring it up a bit. Let's try creating a material for this volume as well. So let's go to our look dev, volumes context. I will right click on the browser widget or the browser window. Again, go to New, Material, Volume. And this time I will call it Environment Volume. And to assign it to our new volume, I will just click and drag. Perfect. So I will go again with a slightly red tint. So in the albedo, change the color to 0.5, 0.45, 0.45. But this time I will go with an extremely low density multiplier, something like 0.001 for now. And I will create a very large volume. So let's go to our scene context, into the volumes context, select the box, and we might also want to change its name. I will call it Environment Volume. And let's make it real big. So on the attribute editor, you might need to scroll down, look for the size, and I try with 4 kilometers wide. Same for the depth, I will go with 4 kilometers. And make it 2 kilometers high. So notice how the volume is now covering the entire scene. Of course, everything looks much darker, but as I mentioned earlier, we can decrease this particular volume density quite a lot. So let's go back to our look dev folder, find the volumes folder, select the environment volume, and increase the density even more to 0.0001. Okay, so it's extremely subtle. This could work, but just to make it more evident, I will increase the density 4 times. And yeah, notice how we have now a murkier background. The sky seems a bit more dense. Let's try combining that with our dust. So go back to our environment volumes dust and turn these on by pressing Shift D. Okay, so this is definitely looking quite good. For now, I will save my file and move on to rendering. Okay, so we're finally ready to render our final image. And throughout the tutorial, we have been working through the 3D view. This time, I'm going to change to the image view that is exactly what you will have when you output your final render. Now, I want to bring your attention to 3 objects that are usually created whenever you create your Clarisse scene, which are a camera, an image, and a path tracer. So usually to generate a final image, you will need all 3 of these. So the path tracer is your renderer, and it will have all the parameters you will need to tweak your final image. The image object is the actual image generated for your render. And of course, the camera, you will need to see through it in order to be able to select your point of view. So in our case, we did generate a camera within Houdini, and this was exported as an Alembic file. So this is the one we're going to use. Actually, the image is looking through this default camera, and that's something I'm going to change in a moment. Now, one very important thing I usually do when I'm about to render is I either change my widget to image gallery. This will show you a thumbnail of the selected image, or the layer editor, which is very important whenever you're creating render layers. And I'll talk about render layers in a moment, but just consider that each image should have at least one render layer. In this case, it's called background. That's the default name. Okay, so let's take a look now at our image object. Here you will be able to define the resolution. By default, it's 4K, but rendered at 50%. In this particular case, for the tutorial, I will render at 25%. And we also talked about each image should have at least one render layer. And you can also click here on your layer editor. You will be able to see the properties for this particular render layer. Now, this is important because each render layer can have different properties. For example, you can render different layers with different cameras or different lights, or even different geometry. So let's set the camera that we're going to use. So you might need to scroll down where you see the rendering tab. And here by default, you have the camera that's created with the scene. Let's change this to DNS10 cam. That is the camera that I've been using to create my scene. Now the renderer is okay. Path tracer is the only renderer that we currently have in the scene. So here it is. And again, you could create different path tracers with different settings or quality and render each layer with different path tracers if necessary. Okay, so let's take a closer look to the image view. So by pressing spacebar and middle click, you can pan. And with your mouse wheel, you can zoom in. Okay. So now notice how the path tracer has 9 anti-alias samples by default. If you want to avoid a bit of this noise, you could definitely increase the samples. Of course, this would also increase the render times. So again, for the purpose of this tutorial, I will bring down the samples to make my render much faster. But in the end, I usually end up increasing the samples to at least 24 or 32. Okay. So back to our image, and specifically our background. I want to save this file to disk. So in the attributes, you might need to scroll until you see the output. And notice the render to disk is by default off. So I'm going to turn on render to disk and make sure to select the frame range that I want to render. In this case, I just need to render one single frame. So I will render from frame 1 to frame 1. And now here where it says save as, you need to define a location and a name for the rendered file. So click on the disk, navigate to your render folder, and make sure to create a meaningful name. I will call this environment tutorial version 1. Now, in case you're rendering an animation, you might want to add some padding for the numbers. And you can do this by using the hash symbol. So if you want a 3-number padding, you would use 3 hashes. And now we're ready to save the file. So the extension for the file is usually an EXR by default. This is fine. But in case you need a different format, you can definitely select between JPEG, bitmap, Targa, and a few others. In my case, I'll leave it at the default of EXR. Okay, so I think we're ready to proceed. One more thing I'm going to do. Notice how currently on the background, we have this grid. This is showing that the background is transparent. What I'm going to do is I'm going to turn on the visibility of the light. Remember, we are using an HDRI image to generate the lighting. I'll just turn it on so we have the sky as a background. So I will go into my lights context, select my IBL light, and look for the unseen by camera property. I'll turn this property off, and you will see how the grid pattern in the background is not longer visible. Now we can see the HDR image as a background, which is fine for this particular image. Okay, so now to create our actual render, we'll go to Windows and look for the Render Manager window. This window will show you the image that you're currently rendering and all its render layers. So in this case, I just have the background render layer. So usually before rendering, you can check the paths. So make sure that the path is available. So in this case, I'm pretty sure this is good. I'll click OK. And now I'm ready to render. So just click render. And depending on your image, it could take a few seconds to render, or a couple minutes, or even hours if it's a very big image. And of course, when the render is finished, your image will be in your defined folder. Okay, so to take a look at my image, I'm going to use Natron, which is a free compositor program. I will open the folder and just drag and drop the image to the Natron interface. This will load in the image. And there you see we have our 1K image. Remember, we render this at 25%. Again, right now, the level of noise that we have is quite high. I would definitely increase the anti-alias samples. Of course, this image took like a couple of seconds to render. My final 2K image with very high samples took about half an hour to render. So let's take a look again at that final image and continue with our last lesson. Okay, so for this final introductory lesson, I want to show you a very powerful and a very important topic, which is rendering layers. Rendering layers will give you a huge amount of control when you create the final composite of your image. And to show you how render layers work in Clarisse, I created this very simple scene. So currently I only have a camera, a few lights, and a couple of geometric objects. Now notice we don't have a renderer and we also don't have an image. So first of all, we need to create a ray tracer and an image object. So let's do that now. So right click on your browser widget, go to New, Renderer, and select Ray Tracer. Again, right click on the widget, go to New, and now let's create an image. And let's rename this image, press F2. I will call this tutorial image. Okay, so now we have everything necessary to create our rendered image. So let's go to the image view. Let's try to frame this image. I will use the wheel. Spacebar and middle mouse will allow you to pan the image. Now notice this time we can't see anything. Let's take a look at our image first. Remember, we need at least one render layer in the image, and currently we have none. So we will need to create a layer. Before we do that, let's just define the final output of a rendered image. So under resolution mode, you can click on user defined and type in the width and the height of the final image. In my case, I will use 1024 by 764 and make sure to render it at the full size. Okay, so it's now time to create our layers. So go to layers, click in add, and create a 3D layer. Let's rename this layer background or BG. Click OK. And now let's make sure to define which camera we want to use to render and which ray tracer. So in your attribute editor, scroll down until you see the active camera. So notice how by default it's set to none. Let's select our camera object. And now under renderer, select our ray tracer. Okay, this is definitely what we expected if you take a look at your 3D view. we're definitely ready to render. So let's define an output for our image. Look for the render to disk option, turn that option on. Let's set the frame range to 1. And now let's define the name and location for the file. I'll go to render folder. I will create a new folder called render layers and call my image tutorial sample. This will be the background layer, and then click on save. Okay, so let's try rendering this image. Go to your Windows, Render Manager, and click on Render. Of course, this is a very simple image. Render will be done very quickly. And let's check our folder. So here I have my rendered layers, and here is my EXR. So I will again open Natron, click and drag the image. Okay, so this is the final render, and currently it's not different from the environment that we just rendered. But what I'm going to do now is create a couple of more layers that will let me separate this image and have a better control in compositing. So let's go back to Clarisse. And let's create a couple more layers. So you can right click on the background layer and click duplicate. And now what I want to do is divide this image in the background, cube, sphere, and cylinder. One thing that you need to consider whenever you're creating your layers, think of them as Photoshop layers. You want your background in the very bottom, and then each layer will be drawn on top of the one in the bottom. So technically for this particular image, we want the cube to be on the very top, then the cylinder, then the sphere, and of course the background at the very last. So I'll make sure to rename the topmost layer cube. The second one will be cylinder. Then sphere. And our background is fine. Now, a couple of things we need to prepare. First of all, we don't want every single layer to be named the same. That would only overwrite the image each time. So let's go with a sphere and change the name of the image layer to sphere. Same with a cylinder. And the cube. Now, if we try isolating these layers, you will notice that currently they're all identical. So before we're able to separate each object into different render layers, we need to create what are called groups in Clarisse. So if you go to your scene, you can right-click on your browser widget and go to New Group. And now we need to add to these groups the objects or geometries that we want to isolate. So first of all, let's rename this group Background Group. And notice on the attribute editor, there's an inclusion list. So we can add objects to this list. In this case, we only want to add the polygrid. So now this group is comprised of only this polygrid object. We can also create groups by right-clicking objects. For example, let's do another group for the cube. I will right-click on the cube and create a group out of it. So notice how this new group in the inclusion list has the poly box included. So that's exactly what we want. So I'll rename this group as cube group. And I will do the same with the cylinder. And the sphere. Okay, so now with our groups created, we can go back to our layers and tell each layer to only render each separate group. And to do that, we can go to the attribute layer, scroll down to the rendering visibility, and you'll notice by default, the rendering visibility for the geometries is whatever is in the current context. In this case, every single geometry within our context. So let's change this to group background. And notice only rendering the floor. Of course, all the shadows and reflections are also being taken into account, which is very powerful. Let's try to do the same thing with the sphere layer. So click on the sphere layer to select it, and under rendering visibility, geometries, select the sphere group. Let's now display the layer, and of course we can now see the red sphere. So let's do the same with the cylinder layer and the cube layer. And that should be all. Let's try to render the entire composite. So let's go to Windows, Render Manager, and notice on our list, now you'll see all 4 layers. Let's now try rendering. Okay, so that was quick. Let's go back to Natron. And here on our render folder, sure enough, we'll have 4 images. Let's bring them in. And if you take a look at the individual images, we'll have our separate elements. And we can composite them extremely easily just with a merge node. So let's merge in the sphere first. Take a look at the result. Again, I will press the M key for a merge node. I will merge in the cylinder. And finally, let's merge in the cube. So I'll press M. I'll connect the A over the B. And with the merge selected, press 1 to take a look at the final image. Now, the huge advantage of rendering your separate layers, as I mentioned before, is you can very easily tweak your individual elements. For example, I'll press the G key to create a grade node. And try changing the gamma of the sphere. Probably we want to make it a little bit brighter. And same with the cube. I'll press G to create a grade node. And let's make the cube a little bit darker. We can also add a color corrector with the C key. And try decreasing the saturation. So as you can see, this brings a huge amount of possibilities whenever you're compositing your final image. I would definitely recommend that you take a look into the rendering layers within Clarisse. They're an extremely powerful tool. So this has been the introduction to Clarisse. I hope with the knowledge that you acquire, you will be able to start rendering some very beautiful environments. Clarisse is a software that I really enjoy using a lot, and I think that it will make your life easier when managing your environments or matte painting projects. I hope to soon start looking at your creations and probably meet you in future tutorials. Thank you for watching and take care.